everyone. So Dr. Ramesh Chandra. Today we are going to talk about the chemistry of group 13 elements. So before going to start today's topic, so first you have to know the basics of periodic table. As you know that periodic table is basically consists of S, P, D and F log elements. Now these group 13 elements are basically belongs to P block elements. Now, this group 13 elements contains boron, aluminium, gallium, indium, and helium. And the corresponding electronic configuration of boron is helium 2s2 For aluminium, it is neon 3s2 For gallium, it is argon 3d10 4s2 For indium, it is krypton 4d10 5s2 And for helium, it is xenon 4f14 5p10 6s2 Now, if you look at the general electronic configuration, valence shell general electronic configuration of group 13 element, it is ns2 np1. Okay. So coming to the one important question, all the time it is coming in different university exam, that how can you account for the differences in chemical properties of boron with other element of the same group. So as you can see that group 13 elements contains boron, aluminium, gallium, indium and thallium. The first member of any periodic table, the first member of any periodic group is always exhibit some remarkable differences in its chemical properties from the rest of the other elements. Now here, in case of group 13 elements, boron is not an exception in this respect. So the reason for such differences are shown as below. You can see that. So the first point is that the electronegativity and the ionization energy decreases down the group. So if you go from boron to helium, so if you go down, so the two important properties like electronegativity and ionization energy gradually decreases down the group. So therefore, you can see that the boron is a non-metal where others have distinct metal properties. So why boron is exceptional? You can see that rest of the except boron, rest of the other metals shows some metal character. On the other hand, boron is it can actually non-metal. So coming to the next point, all the members form electron deficient compound and behaves as a Lewis acid, but acidity decreases down the group. That is important. And due to the absence of vacant d orbital of boron in the valence shell, its coordination number is up to 4, while that of the other is 6 due to the presence of vacant d orbital. So let me try to explain once again that boron, it has vacant absence of vacant d orbital, so the coordination number of boron is 4. On the other hand, in case of other element like aluminium, gallium, indium, and thallium, their coordination number is up to 6. So because of the presence of vacant d orbital. And the next and important point is that non-metallic character of boron reflected from the acidic nature of boron trioxide, while other oxide of other elements are such a basic, and aluminium oxide, it can behaves as a amphoteric in nature. So the next point is that boron can form pi back bonding with any halide elements as well as oxygen, but such pi bonding formation becomes less important if you go down the group due to the increase in the size of the higher member. So the last point is that boron compounds are covalent due to high ionization energy, while ionic character increases in the compound of the element down towards the group. That's why boron is quite different with respect to the rest of the other elements. So coming to the next important question, which is also came in different university exam. The question is, why boron is closely resembles with silicon? Explain. So these are a few important points that you have to understand why boron closely resembles with silicon. So boron shows very closer relationship to the non-metal like silicon. So this closer relationship is due to the diagonal relationship. So which is again you can see that determined by this phi charge by radius ratio is approximately same. So the main point of the similarities between this boron and silicon are, you can see that the first point, both boron and silicon are still gray color solid with marked luster and electrical conductivity. So these are the three important properties both of this element shows, and on the other hand, they have high melting point and both are obtained in crystalline and amorphous form. Okay. The second point is that silicon burns in air form silicon dioxide. Similarly, boron also burns in air producing boron trioxide. The next, the third point is that the the hydroxide of boron and silicon, you can the hydroxide of boron and silicon are like boric acid and hydrofluorosilicic acid. They do not show basic properties. Now, H2BO2 reacts with alcohol in presence of sulfuric acid to form alkyl or aryl borate. You can see that this trialkoxy borate. On the other hand, orthosilicic acid is also formed a series of volatile ester like tetrahydroxysilane. But in the last case, you can see that both the boron and silicon are obtained by a common method of acid hydrolysis of magnesium boride and magnesium silicide. Next coming important point is that hydrides of boron and silicon are covalent and they hydrolyze by water molecule, and both boron trichloride and silicon tetrachloride undergoes hydrolysis by water irreversibly. You can see that when silicon tetrachloride reacts with water, 4 equivalent of water, it forms Si which equal 4 silicon tetrahydroxide and HCl. On the other hand, when boron trichloride reacts with water, it will provide boric acid and hydrochloric acid. The next important point is that when hydrolysis of boron trichloride and silicon tetrachloride are comparable, so therefore both this boron trichloride and silicon tetrachloride undergoes hydrolysis by water to give the following products. Like you can see that when boron trichloride reacts with water molecule, it will form boron boric acid and hydrochloric acid. Then further this HF molecule reacts with BF3 and it will form this kind of compound. The overall reaction is coming here is that boron trichloride 3 equivalent of water, it will provide boric acid and 3HBF4. Now similarly, if you look at here in case of silicon tetrachloride, again it get hydrolyzed and it will form this kind of SiOH4, and the overall reaction is that SiO4 plus 4H2O. That is the thing. So therefore, you can easily say that the hydrolytic products are comparable. Similarly, of their hydrolytic behavior is not unlike due to the boron and silicon are related to as diagonal relationships. Okay. So in the next lecture, I will explain another couple of questions related to group 13 element. Thank you.